Hi friends, today we discuss Laplace transform of periodic function. So what is a periodic function? A function of the form, a function ft is called a periodic function if it satisfies this property, f of small t plus capital T is equal to f of small t. So if you are getting something like this for some function, the function is periodic, it repeats its value again and again. For example, if we take fx equal to sine x, we can write f of x plus 2 pi is equal to sine x plus 2y, and sine x plus 2y equal to sine x. So 2 pi is the period of sine, and sine is called a periodic function. Similarly, cos is also a periodic function. So we try to find the Laplace transform of this type of periodic function. And what is the formula for that? So Laplace transform of f, where ft is a periodic function, is given by integration 0 to t capital T, here t is the period, so e to the power minus a small t ft dt divided by 1 minus e to the power minus s capital T. So this is the formula we want to prove. So what should I do? So Laplace transform ft, we just put in the definition. This is equal to 0 to infinity e to the power minus st ft dt. This is a definition of Laplace transform. Now we break this limit 0 to infinity to 0 to t, then t to 2t, then 2t to 3t, and so on. So we just break it like this. Now we calculate one by one. At first we just fix this as it is. First term we fix, just fix it, we don't do it, do nothing with this. Now try to find the value of this function, this integral. So integration t to 2t to the power minus st ft dt. In this integral we try to find the value, and for that we take the substitution small t equal to u plus capital T. So here t and u are variables and capital T is a constant. So if you differentiate, so we will get dt equal to du. Now we want to change the limit. So t if small t is equal to capital T, then value of u will be, we just put here. So if you put this t equal to small t equal to t, then value of u will be, you will get 0. So t is 0. Similarly, if you put small t equal to 2t, then you will get the value of small u equal to capital T. So now your limit changes to 0 to t, and you put e to the power minus s and put the value of t, which is u plus capital T, we assume here, and t is again I put this value small u plus t. Now just break this function. So this becomes e to the power minus su minus st, and f is periodic, so therefore we just write this thing. So since f is periodic, f of u plus t is equal to fu. Now this term of independent of u, and so therefore this is act as a constant and it comes out in the integration, and we get this thing. So this is the value we get from the first term. Now this is the first term already we have obtained. So in the so we get the integral value of this function in the term of the first function, whatever we get, write it in there above. So now in general, if we take nt to n plus 1t e to the minus st ft dt, we can write this integral as e to the power minus s and t 0 to t e to the power minus su ft dt. This is by the simple transformation small t equal to u plus nt. This is a simple transformation. You can pause the video and just check the calculation. Therefore, this integral 0 to infinity e to the power minus st ft dt is equal to 0 to t e to the power minus st dt. We keep it as it is, and the second term become e to the minus st 0 to t e to the minus st ft dt, and the third term become e to the power minus 2st 0 to t e to the power minus st dt, and so on. Now it just take this value is common everywhere, so this comes out, and we can write this is 1 plus e to the minus st e to the minus 2st, and so on. So this is infinite GP series. This is infinite GP series. So you use the formula for GP series, this becomes 1 divided by 1 minus e to the power minus st. And then we value this. So this is the formula for the Laplace transform of periodic functions. Now we try to prove the second translation or shifting property. So let Laplace transform of capital Ft is equal to small fs and gt equal to f of t minus f for t greater than a and equal to 0 is t less than. Then Laplace transform gt is given by e to the power minus as fs. So in some sense we can say this is the inverse of the first translation. In the first translation we take the Laplace transform in this form and we get function as this, and here this we are taking the inverse root. So try to find this. So Laplace transform is gt is equal to 0 to infinity to the minus st gt dt. Now we can break this limit 0 to infinity to a and then a to infinity. Now between 0 to a, this gt has a function value 0. So if you put here 0, this is equal to 0. So you will get simply 0. And for this, if you take this transform t minus a equal to u, and you find this limit is a, again 0 to infinity, a to infinity becomes 0 to infinity, and you put t equal to u plus a, and you are getting f of t minus a equal to f of u, and just simple calculation, and you are getting this result. You just pause this video and just take 2-3 simple very simple elementary calculation, you get this. Example, find Laplace transform of ft where ft equal to cos of t minus 2 pi by 3 if t greater than 2 pi by 3 and 0 if t less than 2 pi by 3. So we know what is the Laplace transform of cos t. So Laplace transform of cos t is given by s by s square plus 1. So now we want to find cos of t minus 2 pi by 3. So here we use the previous theorem, the second translation property. So here 2 pi by 3, you are translating by 2 pi by 3. So we get e to the power minus as. So here s is fixed and you have a as a 2 pi by 3. So e to the power minus 2 pi by 3 s. And with that you just the Laplace transform of cos t. So you are getting s by s square plus 1. Now another result, this is called change of scale property. So if Laplace transform of ft equal to fs, then Laplace transform f of at. Laplace transform of f of at is given by 1 by a f of s by a. Again, this is a very simple integration. Suppose at equal to u, then we will get a equal to dt du. We take this transformation and now start the find the Laplace transformation. So Laplace transform of f of at is equal to 0 to infinity e to the power minus st f of at dt. So which is given by 0 to infinity e to the power minus s into, what is the value of t here? From here you can find the value of t is equal to u by a. So we just put t equal to u by a and f of a equal to f of u, and value of dt here, from here dt equal to 1 by a du. So we put 1 by a du. So 1 by a is a constant, so it comes out here and you can write everything as it is. So here you have the variable, now this s becomes s by a. So this is 1 by a f of s by a. Next day we discuss some derivative and integration property of the Laplace transform.